Space Station Alpha, this is Houston. We've just been notified by the Space Weather Prediction Center in Boulder, Colorado, that a CME has erupted on the Sun, and it appears to be directed towards Earth. Forecasters are currently determining the specific track and severity of the storm.
Roger, Houston. Keep us posted.
The Sun, our star, is the source of light and heat for life on Earth. Today, we understand the importance of the Sun more than ever. We've learned that we're living within the extended atmosphere of the Sun. We are living with a star. We know that while the Sun supports life on Earth, it threatens life as well. It produces space weather, streams of high-energy particles and radiation that can harm human life and interfere with our modern technology. But under the protective shields of the Earth's atmosphere and magnetic field, life on Earth has evolved and thrived. The Sun was born when gas and dust floating in space were pulled together by gravity. Over time, the pressure and temperature increased, and when they were great enough, a process called fusion began in the Sun's core. During fusion, lighter atoms such as hydrogen combine to make heavier atoms such as helium. This process creates and releases large amounts of energy. This energy passes through the Sun's dense layers of gas and can take hundreds of thousands of years to reach the surface. The light we see comes from the surface and is visible in the form of granules. These granules are continually changing, reflecting the motion of the Sun's gaseous interior. The average size of a granule is larger than the state of Texas. The Sun also has a magnetic field. It is complex and constantly changing. Solar rotation causes the magnetic field lines to stretch and twist, building up magnetic field energy. Strong magnetic fields can bubble up to the surface, producing very active areas where sunspots can form. Sunspots appear as planet-sized dark spots on the surface and have a great deal of magnetic energy. As energy builds up, the magnetic fields can become unstable, producing solar flares and eruptions, blasting charged particles into space. Spectacular features called prominences are also the result of the Sun's unstable magnetic field. All this awesome power can produce sunquakes, solar tsunamis, and even solar tornadoes. This activity peaks every 11 years when the Sun's cycle reaches a period called solar maximum. The most spectacular event during solar maximum is a coronal mass ejection, or CME. A CME is the violent eruption of particles from the Sun's corona, a layer of the solar atmosphere. A typical CME can blast out billions of tons of material at speeds up to several million miles per hour. During solar maximum, these eruptions occur several times each day. When the CME erupts in the Earth's direction, the results can be both dazzling and dangerous. Our planet, however, is protected from the most harmful effects of an eruption by our atmosphere and magnetic field. A CME also contains a strong magnetic field, and the clash of the two magnetic fields can result in what is called space weather. Space weather storms contain streams of energetic particles that impact the Earth's atmosphere, creating beautiful visual displays called auroras. As our use of technology increases, so too does our concern about space weather and its damaging effects. Extremely powerful solar storms often generate large electric currents that can damage power grids. Severe space weather can also disrupt communications and disable satellites. Fortunately, living things on Earth are protected from these storms. However, since astronauts aboard the International Space Station orbit above our protective atmosphere, they can be exposed to high doses of radiation. Solar storms can cause spacewalks to be canceled and rescheduled in order to keep the astronauts within the protection of the space station. Today, solar activity is monitored from the ground and with satellites, providing us with valuable information. Scientists watch the sun closely and give alerts when severe space weather arises. For years, scientists have been using space-based observatories such as SOHO and the twin stereo satellites to monitor solar activity. Researchers continue to use these satellites to gain a better understanding of how the sun works and its effect on our planet.
Go for main engine start. 3, 2, 1, ignition and liftoff.
In 2010, NASA launched the Solar Dynamics Observatory, or SDO. SDO was designed to study changes in the sun in ways no other mission can match. It precisely measures energy from the sun's atmosphere, helping scientists understand the amount of energy that the Earth's upper atmosphere receives. Cameras aboard SDO provide high-resolution images of the sun's surface and atmosphere in 10 different wavelengths, revealing hidden solar activity. Other instruments measure the sun's magnetic field and use a special technique that can actually look inside the sun at the very source of solar activity itself. The SDO team believes that all these measurements will uncover important clues that will help solve the mystery of the solar cycle and will aid scientists in predicting future solar activity. The Solar Dynamics Observatory is one of the ways scientists are learning about the Sun-Earth environment and what it's like for us to be living with a star.
Space Station Alpha, this is Houston. Forecasters are predicting moderate storm levels and low radiation for the CME. We advise caution over the next day, and we will update you when we know the full extent of its impact. By the way, the storm has one positive for you. Take a look out of the cupola window.
Roger, Houston. Wow. We're passing just above the green aurora and right through the red one. Is there anything more breathtaking than seeing Earth and an aurora from space?